All right then, for many of you, most of you, nearly all of you, this is it. This is the last little section for your first year. How do you feel about that? Lights? Don't let the door hit you in the ass, Kevin.
Yeah.
All right, propeller auxiliary systems. I don't think this is much of a coincidence that this particular photograph right here is both blades are in the exact same position. That'd be a, huh? Yeah, prop synchronizer. Well, syncophaser to be more exact. So synchronizer and synchrophaser, which we're going to discuss right after a word from our sponsors.
Who's that today? 56?
No, it's just, I'd open this up, so I thought I'd just say that, you know. Because I was a latchkey kid and I watched way too much TV. All right. Prop aux systems. First thing we're talking about is the propeller prop synchronizer. So prop synchronizer is going to match engine speed or propeller speed if they're geared, but I guess it's still engine speed. No, turbine would be prop speed. So prop speed, engine speed as appropriate, so they're exactly the same. I'm willing to bet Nick was one of those kids, you know, your mom was vacuuming, you had to match the pitch of the vacuum. See? And it got a little obnoxious.
Quit arguing with your sister in there, son.
A prop synchronizer system matches either engine speed or prop speed as appropriate. Sometimes it's the same, as identical as possible. Why? This reduces noise from harmonics. Reduces noise from harmonics. That's that little thing you blow when you play in the prison, I think. I don't know why that has anything to do with this, but aren't you a music major of some sort?
No.
You were in the band?
In high school.
So that was like a semester and a half ago?
Got him.
Explain to us harmonics.
I'm sure it's fresh. It's this
You're my
thing-
guy, come on.
I'll just push the buttons.
It's this thing.
What'd you
blow
play?
into.
What?
What'd you play? Well, isn't everything but drums pushing buttons?
Yeah.
All right. Noise from harmonics. That would be noises we don't like. Important point. It is not used for takeoff. There's a good reason for that. So on this particular system, we are going to have a master governor and a slave governor, as they are called. And the master governor means it's the one that sends out the output. So we can call it output governor and sensing governor. So within a certain range, what happens is, you can see by the drawing, you have a magnetic pickup that's going to go around to this control box. So they're going to look at both impulses coming in from each governor. So to do that, you just put a magnetic pickup somewhere on the governor with a little sensor. Then every time it goes around, it's going to pick up that the magnet went by, and so it's going to send a pulse to the control box. So if it picks up that the output governor here is turning it's going to pick up its speed, and then it's going to look over here at the slave governor, and if this side over here is moving, the slave governor is moving a little bit slower, then it's just going to adjust the governor all on its own to match the other side. So they're going to be lock, sync, in step, RPM. So it has a small range. You can't like do too much, but still, the last thing you want is for this governor right here on this engine to fail on takeoff, and this one go, oh, we're quitting, are we? So that's a bad thing. So you don't have it on during takeoff. You want each one doing their own thing. Not used for takeoff. Let's see. Why? Because if one engine quits, you don't want the other one to follow. Don't want the other one to follow. Now, given that most of these systems, the ones that I'm aware of, are limited to what they can do, I don't think that this engine quits, this engine's not going to follow it all the way to nothing. It'll just back it down to its limit and go, oh, it's the best I can do to match. But still, that's pretty bad when you lose one engine, the other one decides it's going to lose about 200 RPM on it. I don't think you like that. You got bad enough things going on. Operation. All right, so one engine will be the master engine. There is, sensitive subject, a move to change this to primary in a lot of applications. So you may see it either way, master or primary. And the other is the slave, one master engine, and the other is the slave engine, or we'll call it secondary. The one that reacts. So in a twin, it's two engines. In a twin, the left engine, because we count from left to right. So the left, that's the number one. Number one is usually the primary. That's the one that everything has to set to. Now we're going to talk about twins, but you think about it, you get into the C-130s, they have 4 engines. You get into the really old ones, though, at the B-17, Flying Fortress. What's a Flying Fortress? That's 17? Yeah. So you got four radial engines running out there. That's a workload. You ever seen videos of those guys flying those things? I mean, everything is cable. There's no hydraulic assist. I mean, they're like both pulling on stuff. It's kind of interesting. Anyway, let's see. In a twin, the left is okay. So, we'll make that 1. We'll make this 2. That's the way it should have went. 1, 2. The secondary engine has the ability to adjust its RPM. Dang it, RPM. I keep hitting the buttons on here. Its RPM has the ability to match its RPM to match the primary, to match the primary engine within a small range. And that'd be plus or minus 50 RPM. So if it's plus or minus 50 RPM, that is a total of how many? Total of 100 RPM. So you get your props close, turn on the sync, and it'll go up 50 and it'll go down 50. So you got 100 RPM range to play with there.
Kevin, the left and right, that's from the pilot's perspective?
Yes. Because you count left to right, so we're the pilot. Number 1, number 2, number 3, number 4 engine, or number 1, number 2?
Right from the driver.
The what?
Left's right from the driver.
How's it work on the Chinooks?
Yeah, left one's number 1 side.
Well, because front back.
Yeah.
Is that the number 1 rotor? Is this the number 1 rotor?
Forward and aft the rotor.
That's why it should be. All right, equipment installed. Equipment installed on each engine measures the exact prop RPM on each engine. Measures the exact RPM and sends a signal to the control box. It really is so much easier to not write anything and just talk. Which way do you prefer?
A little bit of both.
Well, you don't have to write everything.
True.
Just write them out and hand them out.
Just print it and hand it out? Just, I don't think that would work real well. All right, let me see. Control box, the sensing unit. Oh, the sensing unit. Unit can be a tack generator. What's a tack generator?
Generator.
It is. How's it work?
I assume it just sends a signal.
Yeah, pretty much. It sends a signal. So our ground power unit has a tack generator on it. So it's just a little tiny generator. And so the faster the engine goes, the faster this is going to go. And as we know about electricity, if you take some magnets and a rotor and you turn it faster, what happens to the frequency? Frequency goes up. You could also, power output goes up. So it's going to measure one of those two things. I don't know. It can be a tack generator or a frequency generator. Or frequency generator, frequency generator. Which is what we talked about. They put this under that. So a magnetic pickup. Magnetic pickup. Installed on governor. Which is really how all of these new digital tachometers are working. You just running them off the magneto. You just take out one of the vent plugs, screw in a little sensor in the vent plug, and every time the magnet goes by the little sensor, it's going to pick it up and it's going to send it to the tachometer.
Are there any systems that would flip this and make the right engine primary versus the left so that you're not solely relying on the left engine?
I would venture to guess that modern electronics are starting to allow that. I don't have that information. So it would,
What would be the benefit to that?
not just what he said, if you could swap it. I don't know.
I think some of the multi-engine systems allow you to choose either engine 2 or 3 to be primary.
Okay. Some of the which systems?
The multi-engine system, 4 engines.
Like on what kind of plane would you be talking?
I forget which kind of plane. It was in the book. Because then you could choose, nominally it's engine number 2 in a 4-engine system, and then you could choose engine 3 to be primary,
Okay. Switch it to the other side.
in case you lost engine 2.
So yeah, in a 4-engine that would make sense. You got to pick another primary.
Right, primary goes out.
Yeah. That would make a lot of sense actually. Let's see. The comparison unit. Obviously that receives the signal from the sensing unit. Which should be the tack generator or the frequency generator. And then it will adjust Yes. What did I call it here? Control box.
Yeah.
Yep. So we could say comparison unit / control box. Comparison unit. Well, I'm going to say the comparison unit will adjust the slave engine to the master engine, but it's going to run through the actuator first. So comparison unit will, we'll put send a signal, send signal to control unit to adjust secondary governor. How much?
50 RPM.
About 50 RPM. And this is done with linkage. Say this is done. This is done with linkage. That is paralleled. That is in parallel to cockpit control. All right, so what do you mean by that? So you can see by the drawing on this one, the control box sends the signal over to the actuator. The actuator's got a motor in it that's just going to drive the motor. So that is going to take a flex shaft that is going to either push or pull on the control rod that is in parallel with the control rod in the cockpit, which is to say that when you're doing that, you should see the rod in the cockpit move a little bit, like there's a little ghost right there, because it's all mechanical linkage in this particular system. So if we're talking about a mechanical system, that's what you're going to see. Little prop control going back and forth. Going dang. So, and that's what it's doing. So it has a little actuator. Yeah, it has an actuator. It has a little indicator. Just wanted to do that. The little indicator that I showed you the other day. There we go. The little indicator that I showed you the other day. And it just spins around. So if it's spinning to the right, guess which one's faster?
Go on the right.
It's spinning to the left.
Go on the left.
Left one's faster. I think I did a little. Let me see. Is this a video? It is a video. With sound and everything. How about that? So, I don't know. It's X-Plane or something. So, this would be better if it didn't have noise. There we go. That's. All right, so what I did is I just ran this. So we're in the air, we're flying. It's a Beechcraft, I believe. And you can see the indicator right there. And so the prop sync is right here. It is off. And so I pulled this back, got them out of sync, flipped on the prop sync. And you can just see it starting to slow down and sync right back up.
Essentially the right engine control should go up.
Now pull back the left, which would be number one, and this will start slowing down and matching it that way. That would believe so, yes. So prop sync off, and now they're going to go back out of sync.
Out of sync can they be?
Well, I don't have any twin time as a pilot, so I don't know the exact answer. According to my book, my data that I looked up, 50 RPM. But I think I pulled it a lot more than 50 RPM out of this one just to see what would happen. Let's see. Got it running. See, RPM is right there. Pulled it back. So we're at 5, 26, 27, and 26, so 100. I honestly think it's going to depend on the system. I think some systems will go a little bit more. So I got this one out of sync by 100 and it worked. But again, not a real airplane.
Yeah.
So if it was a test question, though, you'd have to say, be off by as much as
50 RPM.
50 for a total of 100. All right, indicator. Indicator. All right, most twins, not all. Most twins have an indicator. Oops. I don't believe any of our twins here have this system on it. 310 doesn't have it. Skymaster's been gutted, but I didn't see it on there. Have an indicator wheel to show an out of sync condition. To show an out of sync condition. Indicator rotates towards the
Faster.
right. Rotates toward the faster engine. And if engines are in sync, indicator is stationary. That's all I've got to say about synchronizing systems, because there's not much more to say about them.
Follow.
That's how they work. That's what they do. Now we also have the propeller syncophaser. Synchrophaser. Synchrophaser incorporates the features of a synchronizer but adds phase adjustment, which is to say that the props are actually doing the same thing at the same time. So not only going around the same speed as each other, but they're doing it at the same place or out of sync. And I do like the illustration that they use in this particular one. What kind of airplane is that? That is your Skymaster, although I can't quite figure out what this funky looking grill thing is. But it does represent one prop behind the other. And I don't know if we're looking from the back going forward. I guess it had to be forward going back. But anyway, I get tripped up on that. So the phase angle, remember for electricity what phase angle is. Not to give you nightmares, but you can see that both props are exactly in line at 0 phase, and then they moved it off by 20 degrees. So this prop is not doing the same thing at the same time. This is off by 48 degrees, not doing the same thing at the same time. So I like kind of how they did this with the Skymaster, because even though a Skymaster is a twin engine aircraft and you'd think it would sound like any other, they sound so different. And I heard one going, I was walking the dog the other day, and one went over, I'm like, Skymaster. Yeah, it was a Skymaster. They just sound different, the way one prop wash hits the other prop wash and how it affects it. And so use that for synchro phasing. I also would think that, a lot of these aircraft and twins, the props come really close to the cabin. And if you've got it beating back and forth, you're going to have some sort of drumming noise that may be really obnoxious, as opposed to maybe the props going by at the same time. Harmonics. That's the thing that you play. I don't know what that has to do with this, but The old mouth harp. All right, props. Incorporates the features of a synchronizer, but adds prop phase adjustment. Phasing is the relative position of the propeller blades. Phasing is the relative position of the prop blades. We'll say prop blades from one engine to another. Oops. From one engine to another. Otherwise, it sounds a lot like if I said the relative position of prop blades. What does that sound like?
Synchrophaser?
The what?
Synchrophaser?
Nah, if you're talking about the relative position between one prop blade and the other prop blade, relative position between this prop blade and this prop blade is called what? Blade tracking. I just wrote that. It sounded like blade tracking. Now it sounds like, oh, I get it. It's two different engines. Let's see. So phasing, or the phaser. I should put that, the phaser.
The phaser.
The phaser sets the number of degrees, sets the number of degrees of the secondary engine past the primary. And that looks like a good place to take a break.